The question says, out of the following compounds, which will have a zero dipole moment, a compound having zero dipole moment will be non-polar by nature. It is asking which compound is non-polar by nature, having zero dipole moment. For these given compounds, we can draw the structure, then we can find out dipole moment. Okay, we have the first compound 1,1-dichloroethylene. The ethylene means two carbon are there, two carbon, double bond we can mention, and 1,1-dichloro, we have Cl is there, and it is also Cl is there. Okay, and here we have H, and H is there. 1,1-dichloroethylene. Okay, now if you look at here, Cl is more electronegative than carbon, then in this case this is what we have dipole moment. In this case, this is the dipole moment is there. In this case, carbon is more electronegative than hydrogen. Dipole moment goes like this. Okay, carbon is more electronegative than hydrogen, then dipole moment goes like this. Okay, so you can see this dipole moment and here also dipole moment going in the same direction. Okay, when dipole moment going like this. Okay, and in this case dipole moment is going like this, so it is adding up. Dipole moment is there. Dipole moment will not be zero, so it is polar by nature. The compound in which dipole moment is not equal to zero, it is polar by nature, and in which it is equal to zero, it is non-polar by nature. In this case, it will not cancel out. Always keep in mind, if the dipole moment is something like, and both the arrows mark the length, the magnitude of the dipole moment is same. So in this case, dipole moment will be zero because they will cancel out each other. Even if they are in opposite direction, in this case also dipole moment will be zero. But in this case, you can see adding up. In this case, also adding up. Okay. Next, we have cis 1,2-dichloroethylene. Two carbons are there. Two carbon. Okay, ethylene. 1,2-dichloro. It is talking about cis. So both the Cl are in the same side. Here we have Cl. Okay, and this is H is there. This is H is there. Okay. Now in this case, this is the situation is the same situation we are getting, same situation. So you can see this arrow mark in one direction, in this case arrow mark in one direction, arrow mark in one direction, arrow mark in one direction. So dipole moment is adding up. So in this case also dipole moment cannot be zero. Polarity is there, polar by nature. Next we have trans 1,2-dichloroethylene. Ethylene in this case, since two carbons are there having double bond, but in this case trans Cl are present in opposite position. Cl and this is Cl is there. Here we have hydrogen, here we have hydrogen. Pay attention carefully. In this case, this is something is there. In this case, this is something is there. Oh, sorry. Okay, we have arrow mark because Cl is there. Okay, now see this arrow, a magnitude of this arrow is equal to the magnitude of this arrow. Okay, the length of this arrow is equal to length of this arrow because carbon Cl same electronegativity. Here also carbon Cl. In this case, you can see same electronegativity difference is there. So that's why length of the arrow will be same. Dipole moment will be same. And obviously they will cancel out. As I said, if this kind of situation is there, this kind of situation, if length of the arrow is same, then in this case dipole moment will be zero. Here also we have situation, and here also we have situation. So this length is also same. In case of carbon, hydrogen, same electronegativity difference. So dipole moment will be zero. It is non-polar by nature. Non-polar by nature. So you can see the compound which has a zero dipole moment, option C is correct. We have option C. None of these, no, we do not go for the D option. Option C is correct. It has zero dipole moment. If you like this video, please share and subscribe to the channel.